Struggling with my new abode in Warrawee, which is a unit about 4 levels up from the ground, of getting some suitable HF antenna going. And I think Tim's probably said it the most, they're probably not the first that any antenna is better than no antenna, but I tell you what, I've struggled with dipoles to no avail, so thought I'd better do a bit more research and see what I could come up with. And it's evolved to looking at magnetic loop transmitting antennas. These are sort of been known perhaps better as a receiving antenna, but of course you can transmit on them, but there are some technical difficulties with the construction if you're going to do that. So it's customary at the beginning of a talk to say where you come from, to beam any international people in about where you are. So here you'll all recognise this is a map of Australia. This is me with my principal co-worker here. Sadly, he or she is since deceased, so I can say now that I'm totally responsible for my work. And I won't acknowledge at the end, I'll do it now. The person that really sort of got me into some more sensible thinking about this was a guy, Larry Hauer, and I met him on a visit to Hobart in about September last year, and he's a member of the Radio and Electronics Association of Southern Tasmania, basically the Hobart amateur radio group, and I went along to their Wednesday get-together, very similar to here, and Larry was very helpful. He's built some magnetic loops and knew a lot about them, and knew a lot about this fellow Lee Turner, and put me onto an excellent article by Lee called An Overview of the Underestimated Magnetic Loop HF Antenna, and there are soft copies available of this that I can shoot to anybody who would like to have a look, or put it up on the club website. It's actually on the Adelaide Hills website, along with a lot of other information. Colin Christie was also very helpful. He's built a magnetic loop using aluminium as the L, and we'll talk a little bit more about that later. And lots of other people in the club here and at Haddock have also given me some advice. And finally, just off the bottom of the screen there, Dr. Google, of course, was very helpful. So I don't do a lot of on-the-air type radio on HF, but I sort of thought what I wanted to do is to at least get working on 40. 80 would be a bit of a wish list with my problem with small space, and hopefully 20, not so much interested in 30 and the other higher bands, but my aim was to see if I could get something to go on 40 and 20. And I'm got a unit at Warrawee, limited in X, Y and Z planes. I'm on the top, but I can't erect anything too high. There are problems being 4 levels up of providing an adequate ground plane and getting a decent earth. And also, you can't even change the shutters on this place without getting approval from the body corporate. So basically, there's got to be some stealth involved in this. But it does mean I've got to sort of confine myself to a certain area out the back of the unit. So here's looking along one side. This is Marshall Avenue at Warrawee, the street before Fox Valley Road. So I've got a nice little balcony here that's about 1.5 metres wide, but there's concrete down to the ground, concrete here, concrete above, and these metal shutters which can't be fully opened up at all. And I'm jumping ahead a bit, but I did try with dipoles down here. I could get a dipole cut for 40 just, but SWR was never below 5, and I didn't persist with that.
Is that below a flat roof?
It's a flat, yes, it is a flat roof. I think it's concrete on top. I'm not actually sure that it's absolutely sure it's concrete on top. It's a flat roof, lots of air conditioners and things like that up there. So I kicked off with thinking about a dipole. I had a dipole cut for 80 at my house in Linfield beforehand, a sort of droopy dipole, which was a big corner block, and I could actually have one cut for 80 there. somebody put me onto the possibility of a slot antenna, and it's interesting if you'd started with a simple slot, which is a sheet of metal and a slot cut in it, and you feed halfway down each side, you can actually cut away bits of the slot and end up with just something that looks like this, which is still a slot antenna. But this allows you to sort of reduce the real estate that you need, but still problems like with a dipole of you need to have it some metres above ground. I looked at short-tuned vertical whips. I could get just a quarter wave for 20 metres, so it'd be a 5 metre vertical. I looked at that. I looked at putting a slightly longer whip on the end of an ATAS automatic tuner I had for my Yaesu. But I knew that wasn't going to be very successful on 40. But I've yet to fiddle around with that a bit more, but I think I'm happier to go in the direction of this transmitting magnetic loop. What I liked about them is that it's not dependent on needing a good ground. So in a way, if you're worried about RF getting back into you and that kind of thing, it's quite a neat sort of solution. So just wondering at this point, what would people do? Has anybody got any other suggestions on what to consider apart from a magnetic loop in that sort of situation?
Have you tried tuning on the shutters?
Yep, like the old Crystal said, I'm sure on receive it'd be fine. On transmit,
You can't get onto the roof?
not so sure. You can get onto the roof, but that's common property, and I couldn't leave a permanent antenna up there.
Load up the guttering? Can you buy another house?
I could, but I quite like this place, as you'll see.
You don't think the wire around the corner of the roof would be invisible?
Well, it would be, but then it's going to be very close to concrete gutter, that sort of thing. Again, it might be good on receive. I'm not sure about transmit. And I've got no way of then changing the orientation of it. Other ideas, though, for small antennas?
Balloon.
Yeah, well, there are lots of other, kites. We could, there are some big trees across Marshall Avenue. It's a beautiful big tree that goes up about 20 metres higher than I am. And, I could string some...
11 kV goes as well.
Exactly. No, we'll go over at least I think it might only be 240 there, and they're actually insulated because of all the trees. So could do it, but yeah, Dom, and then you're intruding on the common property and then general property. So anyway, I thought I'd see what I could do with magnetic loops. So this is from Lee Turner's article, and it's worth reading really. Basically, he's saying that or confirming that you can get really good performance out of them, and one of the problems, well, let's just read through it. Easily field deployable and fixed site tuned loops have been the routine antenna of choice for many years in professional defence, military, diplomatic and shipboard HF communication links, where a robust and reliable general coverage is deemed mandatory. And I think the point is you see a lot of these sort of big, I wonder what those big circular things were in the front of destroyers and frigates and things like that. And I always assumed they were some sort of VHF, directional sort of thing, but I think that they actually are HF antennas. And Lee's actually done some design work for military purposes as well. And my understanding is that they spare no money with them. With the loop, you want to have it the absolute minimum RF resistance you can get, and they silver anodised copper to have a huge, great loop, some metres in diameter, so God knows how much it actually costs. But
When they can't be heard, they just turn it up 20 dB.
Yep, well, that's right, they can turn it up. But now, the other point is that we'll get on to the size that's optimal, but the lower the frequency you want to go, the ideally the bigger loop you want to have. And the smaller loops do have diminished efficiency. But the point is that a lot of the studies that compare them with a dipole really do compare them with an optimised dipole, and that's going to be 10, 20 metres or something above ground. And most amateurs dipoles are rarely are really optimal. So, so I think that it just tells you that, yes, they do work and the military use them, and also that sometimes the comparisons with other conventional antennas are not quite fair. So really there's another whole lecture on magnetic loop theory. It's very interesting, and I'm not going to go into too much detail here, but I've mentioned that it's free from dependence on ground plane and earth. Basically you need to have an L resonated with C, so you have a loop, which is the L, and then at the ends you've got a capacitance, and to bring it into resonance. And when you do this, if you've got a small antenna, it turns out that you end up with a very high Q and therefore a very low bandwidth. So this is a bit of a problem with the tuning of them, that even within the amateur band, for instance, on 40 metres, with the one that I've built, you'd really have to tune it at least half a dozen times throughout the whole band. If you're only interested in, say, 7045, beautiful. You can just get the capacitor organised for that, and you don't need to touch it precisely. Now, if you want to increase the bandwidth, you just it's a bit of a trade-off with efficiency. So you can do it, but that's always the problem. In terms of construction of it, you need to have as low as possible resistance or impedance to RF as you can in the L, and that's fairly easy to achieve, but this is the problem, and the connections with the capacitor at the bottom. And this is where Larry was very helpful in providing me with an idea to pursue a little further in how to do that. So it's the connections with the loop and the capacitor that are the problems, and the capacitor itself. So you end up with about 2 to 4 kV across the plates of the capacitor. So if you've got an air gap capacitor, thank you. If you've got an air gap capacitor, you need pretty wide spacing, and that might lead you to perhaps think of getting something like this. And I sort of went to the books and started to look up air spacing and all that sort of thing of what's needed. It's very hard to build something that's sort of nice and easy to use, but where you don't have sort of big chunky things like this happening. Now, in a lot of people have talked about this will say that the best thing you can get's a vacuum capacitor, because that can be very small physical size with good no problems with flashover. So that's the ideal thing. You can get a Jennings or Jennings type Russian capacitor for about $200 on eBay, but you've still got to connect that to the L. And if you read Larry's article, you'll see some pictures about various attempts to do that. But then that comes down to construction. If you're going to use copper, you're going to have to get copper onto that nicely, or if you use aluminium, it's all those sorts of problems. So the coil construction's usually one turn, but it can be 2 turns. 2 turns might seem simple. It makes it smaller physically, but it just gets a bit complicated about the feed point and where you have the capacitor. Copper's usually used, but aluminium, despite the DC resistance being a lot higher, is almost as good as copper at the RF frequencies that we're talking about. So aluminium, in fact, is quite a reasonable thing to do it out of. And if you want to have one that's portable, well, then you can use things like coax or Heliac for the coil. In terms of how big it is, and this is where I need a bit of feed or a little bit more discussion. There are some antenna design things on the internet where they talk about the circumference shouldn't be more than 1/4 of the wavelength that you're looking at, and they say that's to avoid self-resonance. And the way I think I understand this is that I know as the L gets of greater circumference, the amount of capacitance you need decreases, and it gets down to just sort of maybe 10 PF or something like that in the end. And I'm thinking that what they're trying to say is that if you get too big on the L, that the thing will resonate with nothing, no C there, and then you've got a problem. But I don't know. Does somebody know a little bit more about that than I?
The outer's just a shield.
Pardon?
It'll be broken in the middle.
Yeah, the outer's just the shield.
So
Yeah.
it's got a wavelength around, then you've got an eighth on each side, and that's going to start resonating if it becomes too much more.
Yeah.
The shield itself isn't going to be effectively shielded because it's going to be resonating.
No, you use the shield as the use the shield.
What I've seen with the magnet uses the inner as the radiator, which isn't where the magnetic currents go, and the outer is the shield, which is just electrically urged.
No,
No, I'm not. No, my sniffer's got a copper tube, and the coils that actually pick it up. The coils that pick it up are 6 turns inside that normal wire. That's an electrical shield against electrical field interaction, because what you want is magnetic field, and it goes straight through the copper shield.
Yes, that's a shielded loop, but this is
Right.
an unshielded
I
loop.
didn't realise he was talking about unshielded.
this is actually the L for the magnet.
No, I thought you were talking about the shielded loop.
This isn't the feed. This isn't the feed, so you're just using the outside. We can connect up the inner if you want
I
to.
can see circumference being an issue if you have a shielded loop anyway, because the shield's going to start resonating.
Yeah, okay. Well, so I think I need to sit down and have a longer talk about that. And that, like I said, it really is another lecture. But anyway, I think it's to do with the fact that it will just start to resonate without any C involved if you get too big. And so there's a bit of a problem if you want to have one that will, say, do 20 metres and 40 metres, that if you optimise it for 40, it's going to be too big for 20. If you optimise it for 20, it's smaller than ideal for 40. So various options. You can have 2 separate loops, if you like, and flip from one to the other. If you stick with the one loop and have it optimised for 20, then you've got to be able to change the capacitance quite markedly, because if you need something like 20 PF to resonate it for 40, it's going to need 200 or something like that for 20. So what Larry said to me was that what he did was he used copper pipe for his L, and he soldered some plates onto it for the capacitor. And I wondered if I really could get away with just cutting. What I did was cut some slots in the end of the tube and then flatten them out. And if I could just interleave them like this, that I might be able to get enough C. And I started sort of going back to basics about plate size and dielectric and things like that, and thought that I could make that work.
That's not a real good photo, Phil. Is that a squashed bit of copper tube?
So this is the copper that's got a slot cut. If you imagine that went to there, I cut a slot like this, and then the 2 hemisphere bits I just squashed out. Then I actually went as far as buying some polycarbonate from Bunnings. I've got heat shrink here. I thought about different things, but you need some sort of dielectric that's going to give you more capacitance than just air if you're going to do it this way. If you're just going to use air, you've got to use much bigger plate sort of area. And you've got to make sure then that this is going to be okay. If you're going to feed 100 watts in it, you might have 3 kV across the plates here. So this is how you learn things as you go. I thought, oh, what I'll do is I'll drill holes in it and I'll put some nylon bolts through it, and that'll mean then that I should be right, shouldn't I? Well, and I thought about that and I thought, well, no, because that's going to put holes in the heat shrink, and then potentially you have a little air space that it's going to arc across. So, not throwing the whole thing away, I came back to putting some bits of wood across the top here and squashing them together, and this is, we can have coarse tune and fine tune by slipping these dots up and down there. Ultimately, if you're going to be changing things frequently, you need to get something better than that. But this is sort of...
Sell that to the military.
That's right. This is my first prototype. Bear with me. And of course, when it rains, you know, if you don't get down to the rain, the wood swells up and that changes the capacitance, and you know, all sorts of things happen. Anyway, that's where I'm up to with it.
So you didn't use cable ties or duct tape?
Oh, we'll get to how the feed line sits in the L.
It's only a prototype, Phil, isn't it?
It is. Okay, so then we're down to how do you feed this thing? So what Lee says is the best thing is to use a fully balanced Faraday transformer coupled subsidiary broadband impedance matching loop with a 5:1 diameter ratio, and that's the preferred way of doing it. Now, I'm not quite sure I understand why this is a Faraday loop or what a Faraday loop is, but anyway, just from a structural rigidity point of view, because this thing's got to sit inside the loop, I preferred that over that because this bit here is going to be all wobbly. So basically, if you think the signal's going to come along here, this is electrical now from your transmitter, along here, along the middle here, and then to the outer there, and whatever that does there, then I guess it goes up up here. Not quite sure I fully understand that. An alternative to feeding it that way, though, is to just use an open loop, like an unshielded loop like this, where you just have the inner and a loop going to the outer. So you can do it like that with a bit of copper wire, or like this with a bit of coax if you want to. That's just going to the centre conductor's going to the outer there, and the outer's just to the outer there. So effectively, electrically, it's the same as that.
It's possible to focus that a bit better.
Sorry?
Anybody know how to focus the machine a bit better?
I think it might be the quality of what I've done possibly, but
No, that's the best you're going to get.
if it can be. Did somebody say we needed a new projector? Was it?
Russell said that.
Now there are different ways of coupling it. You can use a gamma feed. Can use a gamma feed, a fixed one or an adjustable one where you can slide this along to. Oh, hang on. I think it might be that, but it just slide along. Anyway, you can slide along to change the feed, and you can use the sort of transformer matching. What was that? Something on the bottom there.
Conceptual and
Can't read my own writing. Anyway, this is a sort of transformer matching that you can use.
Phil, I've been following your journey since the middle of last year, and you ring me up and say, can you hear me on 7045 on that? But I think I'm I'm probably one of a few people here that know you're not planning to put a tunable capacitor there, are you?
Yes, ultimately. Well, no, actually, I think I've almost.
Not as we understand a tunable capacitor.
No, well, no. I think I'll get onto that because there's a version of this which was published in Amateur Radio end of last year, which is designed for portable use, where it has a sort of feed with a capacitor and you can tune it fairly easily.
Okay.
But the problem then is putting just voltages and things like that through it. It's just very hard.
When we talked on the phone, the idea was that the flats on the end of the tube became the capacitor, and that was where your critical spacing came in.
Correct. Yep.
Correct. And you're not, as that capacitor on your desk,
Yep.
you're not going to have one like that at the base of the loop, are you? The tuning capacitor on your desk.
This is a cut down version of what I've built, if you like, except I haven't split the tubing. I've just put it like this, and in fact this is one that should be the right diameter for 2 metres. I thought I might give it a go, and I think that sitting on the top of my car might be better than something sticking up that always gets caught when I drive into my garage without checking the height. But that is the capacitor. So the point is that it's important to have as least resistance as possible between the L and the C. Well, there's the 0 ohms resistance. So if you can make this C work, whether you want to have it fixed or variable or whatever, that's going to be ideal. Anything else, you've got where you want to vary it, you're usually going to have to do something where you're going to have to connect up the L to the C.
Yeah.
And
There are plenty of magnetic loops out there that have a box at the bottom with a knob on the front,
yep,
right? You're not going to have that as such, really, are you?
not with this setup, but what I had originally in mind was with bits of wood that, however I did that I can just organise something to squash it and open it. And do it remotely. So, you know, I think it's still possible to do it, but I need to work on that a little bit more.
Okay.
So I had fiddled around with it, but inside my lounge room, inside my property here on the balcony, and I finally launched out onto common property here and put it up here. So here's my loop, which is about 1.3 metres in diameter. So that circumference is about right for the maximum circumference you can have for something to work on 20. And I think I've got another shot that shows it a bit better, but my capacitor's here at the bottom and the loop feeding it, the Faraday loops at the top. And here's the feed line here. And with this, either there, or even inside, I just couldn't get the SWR below about 2.5. And it's a bit unclear in Lee's article. He talks about putting a choke in close to where the loop is, and I wasn't quite sure whether that's sort of a necessary part of it and whether that would make any difference to this, whether I've got some sort of common mode currents that I need to get rid of. So maybe with some discussion afterwards, people might help. But I did try when I had this fed with some RG58, whatever that smaller diameter coax is. I did try a choke without really thinking too much about how many turns and diameter and stuff, and it didn't seem to make any difference. But that's something more to work on. So I think the next slides, these are the ones where the audio didn't come out, but I'll play them for you at the end to show you, because I did get it going on receive quite well, and I was pulling in VK3s, VK4s, VK5s very easily, some good VK2s, and I can play you some audio of that at the end. So certainly on receive it's okay, but I just wasn't all that confident that the SWR at 2.5 about pumping too much power out through it. So here's where we had it all. Who asked me? Greg, I think, asked me about how I was holding it all together. Well, here's how it was sort of all been held together. There's the capacitor there. This is the other end of the loop, and this is the Faraday feed for it here. And it was just that I had the orientation of this like this. In this shot, this is looking up to the sky, so the bit of wood's just to help keep the loop in plane with the coil. So this is it looking from my living room out to my balcony, and then beyond the balcony is the common area. So the previous shot showed it out in the common area there. This is just within my property. And I can assure you that this, the loop here is perfectly in plane with this, despite the slightly bodgy look of it. But obviously you can see that's prototype for low wind conditions only.
Is that loop horizontal, is it?
That's horizontal. So you can run them horizontally or vertically. You end up with a null like this. So that's not bad for giving you a pretty omnidirectional sort of propagation pattern.
How directional are they if you put it vertical and add it on a rotator or a...
Yeah, they are quite directional. There you've got a null here. So it's sort of, the radiation's a bit like a
figure of eight,
a donutty thing all around it. Now still with this, I've still got a SWR of 2.5. Just like to draw your attention here though, so if anybody's got any ideas about what to do, whether I need a choke or I've done something stupid here, but about what I can do to improve it, I'd be grateful. But just draw your attention to this. Here's 7048, which is the centre frequency here. SWR's along here. And you can see that the SWR at 7048 minus 47, so just at 7 is going to be 4, and 48 plus 47, 95, 7095 is also going to be 4. So you can appreciate it's got a fairly high sort of Q. You go from 2.5 up to 4 in the space of just 50 kilohertz. And that's it. That's characteristic of all of these, and that's why you've got to retune them just over each band. You can't just have it broadbanded enough to work on the whole band.
It can be a big benefit though to have a narrow band antenna, because if you've got some strong station a bit further up the band, it's not going to affect yourself.
Oh yeah. Look, as long as you can retune it, it's beautiful, and having that directionality is also very helpful. And the other thing is that on receive, it's just brilliant because you just don't get all that electrical noise, and in an urban environment that's a real issue, and particularly then if you're around a lot of local electrical stuff. I've got air conditioners within 10 metres and all of that sort of thing. So no, on receive they're fabulous, and I hope I can show you in one of the WIA feeds that I got about that. Just apropos what you said, Russell, this came out in amateur radio just at the end of last year, which was loop and tuner for 1.8 and 3.5 megs. And here's the schematic for it. So sorry it doesn't come out too well, but basically you've got the loop, you've got a couple of variable capacitors here, variable capacitor here, and that's coming straight into the feed from the transmitter. And I've got the bits to build that. I was going to build it down in Native Dog Flat. Didn't quite get around to it because of a bit of an issue with bushfires and so on. But this is just a 3-page article, and here's a little box with the 2 variable condensers in it, and so there's a tunable one. But I don't think you could put more than about 20 watts through that without it arcing. Here's this is just the outside of the box, and it just had normal HF type connectors here, and this is the just ordinary coax. We're using the outer for the loop, coming around something like that. And look, I'm not sure what connections what. I think these might actually be for the loop, and this is the antenna feed. But that might be something that I might end up just using at home anyway, and just seeing how it goes. The trouble is you do want to be able to transmit something decent on it. As I said, just a 3-page article, which is fairly simple. And this is the video I couldn't get to play, but I will get it to play at a subsequent time and show it to you. I'll get the right codec. The bane of my life. They say you shouldn't give lectures with anything to do with children or animals, and videos is the modern day thing that you really shouldn't do too. So it's just going to take me a little while to get these audios to play, but I'm happy to, if somebody's got some comments to make while I get the audio going, that'd be good. What direction to go in?
Look, I get your SWR down. It probably means the pickup loop is the wrong size, because you're not getting a match. It's a transformer effectively.
Right.
So you've got to fiddle with the size of that pickup loop.
So
you should be able to get your SWR down.
So yeah, okay. So it's exactly the 5-to-1 that's recommended.
You'll probably find it's not 5-to-1. You'll need something different.
Yeah.
So get bigger or smaller, or try squishing it to pretend it's smaller.
Yep. Okay.
And if it doesn't get better when you squish it, then you need to build a bigger loop.
Yep. Okay. Well, I've squished it a bit,
Yeah,
and in fact, it's recommended to squish it a bit along the bit that's close to the copper L. But squishing it, that'll make it effectively what, shorter?
Less coupling.
Yeah. Okay.
Do they make SWR better or worse when you do that?
It didn't make any difference actually, but I was a bit limited to how easily I could squish it and keep it in plane and all that sort of thing. But okay, so thanks for pointing that out. I wasn't aware that would change it. What about rotating it slightly off plane?
Yeah,
Will
that works too.
But will you lose coupling? Like,
It reduces it. The only way to make more couplings is to build a bigger loop.
yeah.
I guess, you never know. Depends on the
You
impedance.
might want less, but if you want more, you have to build a larger coupling loop.
Yeah. Okay. Well, it's a hassle soldering up these loops, as you can. Well, for me and my.
Use an unshielded one just for tuning first.
Sorry.
Use an unshielded loop just for tuning first to make it easier, just out of a bit of wire.
Yeah. Yeah.
Or just go for a gamma match.
Yeah. Gamma matches just seem complicated.
It's easier.
Is
The other
it?
thing is if you're going to have it horizontal, you need to get it fairly high off the ground.
Well, that-
Whereas if you have it vertical, you don't need quite so much.
Yeah.
You need maybe just the diameter of the loop up off the ground.
Yeah. In fact, that's one of. It's a good point to point that out. That one of the things is that when it is vertical, you only need it one loop diameter off the ground. So now, if you put a dipole like that, I'm sure you're going to run into all sorts of trouble.
So I just want to check something because something's not quite adding up to me here. That loop, there's no connectivity right around the loop. You're not feeding in something that goes right around and comes back. It's not connected to the far end. Is that what you're saying?
Plus the far end. Large loop.
Let me just go back.
So it's a continual
Series
conductor with
LC.
a capacitor in series with the loop.
Are you talking about
It's
the?
not a magnetic loop.
You're talking about the feed or the magnetic?
No, the main loop
Yep.
is not continuous around all the way around.
Well, it's a loop with a capacitor on each.
And you feed in
On the
some
ends.
capacitor.
Sorry, no, you don't feed. No. You feed with the coupling loop opposite the
So
capacitor.
what you've actually got is a halo antenna, which is not a magnetic loop.
Why do you say that?
Because the halo antenna is a magnetic loop has current flowing all around the loop.
It does have current. It does have current
But
flowing
it
around
stops at the
Displacement current.
it's
halo can be fed from either end.
it's resonating.
If it was a magnetic loop, it'd be firing all the power at the sky.
If it was what?
If it was a magnetic loop,
Yep.
all the power would be firing up and down, not out. A magnetic loop, you've got to fit vertically because it radiates out through the loop in both directions.
No.